Hello, good morning. So my name is Parameswari, Krishnamurthy. I am coming from IIITH Hyderabad. I work in the research center called Language Technologies Research Center. So today we are going to talk about or discuss a lot about the fundamentals of NLP. Okay. So how many of you have some prior understanding on what is NLP? Good, only two of you. So for most of you, some of you here. So NLP is a new field for some of you. Okay, how many of you use any of the language applications? Google Translate? Most of you. ChatGPT for your assignments. Alexa? Siri? Any other voice assistants? Anything else? Gemini? Bot? Earlier. Okay. So that means all of you have touched upon some of the language applications in your daily life. What do you think? Do you think that it's good to have such kind of applications? It's good, right? And have you ever experienced the same kind of thing in your mother tongue? Same application in your mother tongue? Other than Google Translate or any other translation engines? No. Let's think about a scenario where, let's say, my mother tongue is Tamil. Let's say I want to give this lecture in Tamil, but most of you here don't understand Tamil. But you want to listen the same speech, same information in your own language. Won't it be good? It will be good, right? So that's what we need through the language technology. We want to break the language barrier. And India being a multilingual country with how many languages? 22 scheduled or official languages and more than 700 plus languages. Okay, so definitely we come across a lot of language problem, right? So let's say South Indian going to North India could not speak Hindi, and North Indians coming back to South India, they cannot converse in the South Indian languages, right? And northeastern part of India, very, very rich linguistic landscape that I could say cannot communicate with other parts of India, right? So language barrier is a biggest problem, especially in a multilingual country like India. So more than how much English needs this application, India requires this application. Okay, it is not a useful application, it is a usable application, especially in our context, right? So NLP in one way helps us in building such kind of applications. So today's talk, I'm going to talk about some basic introduction about NLP because some of you are very new to this field. And I'm going to take only text as a medium for us because a lot of multimodality are important in understanding language, either speech or vision or image or gestures, right? There are many things are part of language, but I'm going to talk mostly about the text processing today because given the point that it is only 2 hours, I don't want to get into too many things. So I'll talk about some text pre-processing techniques and how the texts are represented and what kind of text analysis are the tools and analytical applications that we require for our languages. And in the text generation, I'm going to take machine translation as one of the example. But there are many more parts. Question answering is one of the generation part. So I'll talk a little bit about machine translation. And we'll also talk about how to build different kind of models. Okay. So it's I'm trying to make sure that I'm not taking too many things, only about a small problem, text problem. And from the text problem, how to generate language and how to build a model for generating that language. Okay, so we all know that for a human, the most important thing is communication, right? And we are different from other species because of our communication. And we have the ability to use the language. Now, for the communication, definitely, language plays an important role, right? And now humans are master of this language. Have you ever seen, other than human, any other species using language? Okay, so let's say dogs barking at each other, or bees dancing around each other, or cats making meow sound, there is some kind of information as a signal that's been communicated across the human, like animals, right? But this animal communication is a limited one, and it will not have meaningful sounds like what we have, or words, or sentences, or recursiveness that we can try to use. We can keep on adding too many information within one particular sentence, right? So there are a lot of design features of language. Human language is not there in other species, right? So now, since our goal of this whole NLP activity is to mimic the human mind in terms of language analysis and generation, we need to understand how a human mind works. So cognitively, we need to understand how we acquire or learn a language, and how we are storing words, or how we are networking with words in our mind, and how we are generating sentences, and how we are making use of different contexts while generating meaningful, well-formed, grammatically acceptable sentences, right? So human mind works in a very, very fascinating way. We cannot definitely break our brain and see how it works. But if we want to create that neural networks of what we have in our human brain with a computer, how are we going to do? So, now can a machine do this? Of course, we have a lot of examples already. You said you have used some of the application. Yes, machines are able to do it. And NLP in one way enables these computers to understand, interpret and generate human language. Okay, so as a speaker of any language, first we need to understand the concept, and we are encoding that information and we are decoding that information to the speakers, right? So now NLP should do everything. It should understand the language, it should interpret the meaning out of it, and finally it has to generate the language. Okay. Now, the terms like computational linguistics and NLP at this particular time more or like same, though NLP looks at the task from more of engineering perspective, whereas computational linguistics looks at the same problem from the linguistic perspective. So by the way, linguistics is again a study of languages, looking at the languages, studying them from the computational linguistics from the computational perspective. Okay, so most of the time NLP people works with different kind of field because they are dealing with language data, right? Language data is not numerals 1, 2, 3 kind of thing, right? It has lot of information, and sometimes informations are underrepresented. Okay, if I say something like pass the salt. Now in this, if I'm not giving any context to you, but you know that what do I mean by pass the salt, right? I'm not passing the salt, but I'm asking you to give me the salt, right? So there is some kind of discourse all of us will understand, right? But now how to give this kind of discourse to the machine? There we definitely need a lot of linguistic knowledge. Not only that, in other fields. And there are different kind of application we can build using this understanding, interpretation and generating of languages, starting with chatbots, right? Sentiment analysis, machine translation, speech recognition, speech synthesis, okay, whatnot. Any kind of application that you are seeing today can be built using this kind of technology now. Okay. So now the major things that need to understand under NLP is it actually comprises of 2 important things: natural language understanding and natural language generation. Now machine should do both the tasks perfectly. Okay, natural language understanding is done. Actually the task is being taken by the human for the computer, for the machine to understand the language. Whereas generation is taken by the computer and generated by the machine. Okay, one is we are working for the computer, another one is computer works for us, right? So in a way it is give and take kind of policy. Now if we are doing that one, between language and computers we need that NLU. Between computer to language generation we need NLG. For example, ChatGPT or any LLM are generative models, right? It only generates the language. How it understands the language, there are different kind of techniques that they use, different kind of deep learning methods that they use to understand the language. Humans are not giving explicit rules to understand the language, but we are giving only data points. Okay, from the data points, it understood the language and tries to generate the language. But on the other hand, NLU is also much important part, because if it is not understanding properly, it will hallucinate. That's why most of the time when you ask some question, it gives you some other answer. If you have played around with any of the LLMs, right? So now understanding and generation should go both in hand when we are working with NLP. Okay, so these are some of the applications I'm just trying to list here, starting with language translation, any other smart assistants like Siri or Alexa kind of thing, and document analysis goes through your document, try to see, understand the document, identify the topics out of it, try to build its own summarization, right, kind of techniques. And in online searches, definitely search engine uses a lot of NLP techniques, right? When you give a query, the query may have different kind of semantic interpretation. It has to understand all the concepts and get the proper, exact results for us. And predictive text, we all don't want to write everything. When I just start typing, the next word should be predicted, right? And summarization, I don't have time to read the complete newspaper. I just want a gist of the newspaper or gist of any research article, summarize it and give it to me. And social media monitoring, any chatbots. These days, most of our banking system works with chatbot. We don't know whether we are talking to a person or we are not talking to a chatbot in the back end, right? Sentiment analysis. Let's say a new iPhone came into the market. What is the quality of it? Whether I can buy it? Is it worth to put a lot of money on that one? We all think a lot of ways and we try to go for, okay, Amazon, what is the star it got? What kind of analysis people do on that part, right? Is it a movie released? I want to see the movie, but I want to see the review out of it, right? Sentiment analysis is very much important these days because we are all consumers one or the other way. And email filtering. I don't want phishing emails, spam emails to come into my inbox, right? So what not? There are many other fields NLP is being used more actively because language is a human property. Without language, we are not able to survive. Whether it is a spoken or a text or a gesture, it's the most important thing. So wherever we use communication, we need some application there, right? So, but why is it so hard? Let's say when I want to build a small calculator, what kind of algorithms I want? I know how to add, I know how to subtract. I can just create some kind of mathematical operations. Just calculator is ready. But is it like a calculator? Is it language is like a calculator? It is 1 plus 1 is 2, but not all the time. Man plus yes become men, child plus yes become children, book plus yes become books. So there is a lot of idiosyncratic pattern when language generates anything. And the way I speak about a concept and the way you speak about the concept, the choice of words differ, right? But 1 plus 1 is always 2. But 2 can be represented as 0 plus 2 or 1 plus 2 or 2 plus 0 in any way, right? So it's a more of non-deterministic approach. It is not a deterministic approach. So since language is a non-deterministic approach, way of building things, there are a lot of challenges that we could see. I'll take some of the examples here. The man couldn't lift his son because he was so weak. And the weak is actually back referencing to someone. Who is that? Is it a man or his son? The man couldn't lift his son because he was so weak. There are many interpretations here again. And the man couldn't lift his son because he was so heavy. Okay. Mary and Sue are sisters. Mary and Sue are mothers. How are Mary and Sue related now? Are they mothers of same children? Definitely in our society it's not accepted. Or there are many ways of interpreting. At least we use different kind of knowledge to interpret it. And let's take the last two sentences. John promised Bill to leave, so an hour later he left. Now who is leaving? John ordered Bill to leave, so an hour later he left. Now who is leaving an hour later? In both the construction, it is totally two different things. Though the construction looks the same, only there is a change of one main verb, changes the complete interpretation of the language. Right? So what is this? This is the complexity of language, one of the important complexity of language. And languages are ambiguous again. Okay, I'll just give one small sentence to take you into why NLP is hard and what kind of things that we have to do. Let's say this is the sentence. I found his train in the pen. Is it an acceptable sentence? It's not acceptable. Is it a grammatically correct sentence? It's like he found, instead of I'll just use he so that it will be little clear. Or he found his pen in the train. If I change the order, it's fine. Okay. But this is also grammatically accepted. But if I give a context, you may also accept that this is the correct sentence. So for that, I'll start with a small story. How many of you have seen the movie Toy Story? Most of you. Did you like the movie? Yeah. Maybe you can think about classifying the toys using ML methods. Let's say there are a lot of toys, right? So that's also one of the things that you can think about it. But yeah, coming back to the story, there's a little, I think, what is the name of that boy in the Toy Story? Andy. Okay. So Andy had a toy, and it is a toy train. He was playing with the train and he lost the train. And he started crying, and his father came in and asked, okay, why are you crying? And Andy said, okay, I lost the train. And his father searched all over the house. Finally, he found his train in the pen. Okay, now at least you understand about what is train, not about the pen. You know that the train, what we are talking about, is a toy train. Now, he found his train in the pen. Now, what is this pen now? It's a play pen. So, pen has two interpretation now. It can be a writing instrument, or it can be a pen where some things can be kept, like either pig pen or play pen kind of thing, right? So, given the context, the cultural context, pragmatic context, world knowledge, are you able to accept this is a correct sentence now? He found his train in the pen? Yes. Now, to interpret anything about language, what we need is a complete window of context. We cannot take anything in isolation. Words in isolation cannot help us. Sentence in isolation cannot help us. We need the complete context. Only then we understand, okay, this is an understandable thing, right? So now for the machine, for an NLU, what we need is complete data. A huge amount of data with context. How we are processing the thing, that's where the other machine learning techniques come in. So as I just told, ambiguity is the problem in languages because it was ambiguous. If I don't tell the story, you might not get what I meant. Similarly, if I say I saw the man with the telescope, whether I have a telescope or the man with the telescope, it's difficult. And context and semantics is very much important. And languages is a very beautiful thing again. Lot of varieties in languages. We cannot standardize anything. Everyone speaks standard language. We have to see that way. Okay. So there are a lot of varieties, lot of dialectal variation, lot of different kind of interpretation that we can bring in. It's a more of a subject creativity. So now NLP models need to be adaptable to multiple languages and dialects. These are all challenges for us. And evolution of language, definitely that happens as long as human evolves. Human finds new things. Language also evolves along with that one. For example, there is a disaster like COVID happened. Language also evolved with a lot of new words. Language also evolved with a lot of constructions based on only that particular domain knowledge, right? So language evolves along with us. So tomorrow there may be something else. So language comes up with a lot of new things about it. So the model that we develop, it should take care how our language works. So any NLP model is not a final model. As long as we grow, we have to keep building new models. So Gemini or GPT cannot be one version. It can be hundreds of versions after hundreds of years also. Okay, so that's important. And data quality and quantity is another major issue with NLP, because if the quality of the data is not good, what goes in, the same thing comes out. Garbage in, garbage out. In machine learning, if you are giving a data, it learns from the data, it represents the data, vectorizes the data, and it provides the same thing when you want to generate, right? So when we want to develop any application, data quality and quantity also matters. And computationally, there are still some complexity. Why can't each institute or each individual build something like Gemini or build something like ChatGPT? We have facilities like Colab, let's say. We have facilities of Kaggle platform. Why we are unable to build something like that? Because it's computationally very complex. That's also another important problem with NLP, especially with researchers. When you don't have a good computing facility with a lot of GPUs, processing the huge amount of data will be again a problematic thing for us, because transformers are computationally very intense models again. Okay. And another important factor, okay, we have everything with us. Finally, whatever we build, can it be a bias-free model? Let's say a lot of data are being taken from Western countries, and the model is built on Western, thoughts. Will that be suitable for us? There may be some bias, there may be some cultural differences, right? So mitigating them is very important, and trying to make sure that it's for the particular society. Even if a society has some kind of hierarchical thing, it should not be carried away. So there are many issues. The society itself can have bias, the way how men and females are treated. Most of us know the issues, right? If the language is more of derogatorily indicating the female, I don't want a model learned from that kind of data, right? So any model that we need is a bias-free model. So that's another bigger issue. So now I think I just have given you a background on what is NLP, and NLP is not like a calculator, just given some operation, take it out. So we are actually dealing with something called language, which is nothing but a human mindset, right? So, okay. Now let us get into the actual architecture. So how does this NLP works then? So there are different stages we need to do in any NLP application. Okay. We'll start with data collection, and the data comes through different parts. It can be a web scrapped, or it can be published materials from books or written documents. Okay, it's again recorded speech, or it can be anything, right? So data collection is most important thing. I told you about the quality and quantity of data already. And text cleaning is important. Okay, I have scrapped something from the website. Whatever I scrapped will not be ready to be modeled. There may be a lot of tags, HTML tags, there will be images, there will be some kind of other unwanted information which is not required for a particular application. We need to do some cleaning. Then we'll go for some pre-processing. That's the most important thing. I'll talk about little more later. And feature engineering. Then go for modeling. Then evaluate it. Then deploy it. Then monitor it. And model update. Keep coming. Okay, so Gemini or ChatGPT is not final. It should keep coming. We have to keep making these models. Okay, so the pipeline like this will keep going on. Any new data comes in, we have to fine tune with the new data. with the existing models. And let's say I want to leverage a particular model for a particular domain. Let's say healthcare, I want to use this model. I have built a model in a normal data set, but I want to use it in a particular domain. So you have to add some more data, fine tune it with the same model, right? So this process keeps going on and it's a never ending problem. Maybe it can be automized later. Okay, so the automation of whole process might happen, but again the intervention of human intelligence is always required, because it should not generate something unacceptable, right? Especially in the fields like healthcare or legal or any other domain which is very, very sensitive to humankind, it should not generate something unacceptable. Okay, now what is this? I talked about this data collection, text cleaning and pre-processing. I'll just talk little more on each one of the parts and see what kind of effort we need to put in building an NLP application. I'll start with some pre-processing. Again, I'll keep the data collection inside the pre-processing itself. So we gather data from definitely different sources, and we also look for open source most of the time, right? So when you are given a task of building any model, immediately the best thing what we do, go to Hugging Face, see whether is there a model or is there a data. All of us do that one. Right? That's because building data set is not so easy as we think. And scrapping the website is not so easy as we think. Okay? So building data set itself is a huge important thing. Of course, some of the organization from here itself, AI for Bharat kind of organization are giving us a lot of data, and there are different kind of other institutes, research things are making it open. Okay, at least I would say for Indian languages, we have some data. We are still low resource languages. We are not highly resourced languages. So some languages are called as high resource languages according to Common Crawl data. Common Crawl, you know, so data center where they scroll different kind of data. OpenAI is built on the top of it. Gemini is built on the top of it. It's a huge data set. And they actually classify the languages with more data as highly resourced and medium resourced, low resourced, and like very scarcely low resourced languages. Okay, and apparently other than Hindi, which is a medium resource languages, most of our Indian languages are still in low resource or no resource pattern. Okay, so that's another problem. And quality, as I told, it's important. And privacy and security is another important thing, because there may be some personal data or very sensitive data, right? For example, when we are working with some kind of health domain, medical reports may contain names, age, sex, and other details, which we don't want the machine to learn from them. Some of the things we need to mask it properly, right? Otherwise, it will create a bias concept to the machine itself. And data accessibility is another thing. How are we going to store the data? What format we are going to store the data? Is it just simple JSON or a text or a HTML? What kind of format are we going? What kind of model requires what kind of thing is another thing that we need to discuss before going into the any model. And data volume is another important thing, because when you want to build an applications like machine translation, it involves two languages, right? So both the language properties should be part of the data set that we build, right? So we need a huge amount of volume of data, because languages may have a lot of divergence. Languages may have some kind of cross-lingual differences. So if data can capture all these kind of differences, then it may able to provide us a better model. Okay. So depending upon the application, the volume size changes, and variety of data is important. Let's say we are taking a data from only, let's say, movies. Most of the time it's dialogues and conversation, right? So it might work better for such kind of concept. But if you are using the same model for some other domain, like say for scientific conference or a classroom setup, that data set will not help us, right? So we need a variety of data set if we want to use it in a all-purpose domain-free context. And As I told you, bias and representativeness are very important. The data should, let's say when you're working with building any application, it should consider different kind of age groups, different kind of gender, different kind of regional places, right? So we want data should be a more representative data. It should not be taken from one particular place all the time. So that's another important thing. We should be very, very careful when we are building a model, because what we give, that's what we get. So when we get, we have to make sure that we are giving the thing as a representativeness of language. Okay, so language is not one man's property again. It's a society. So this is again, okay, we got the data. We make sure that we followed all kind of criteria and we finally got the data. Now, how do we going to clean it? As I told you, there may be different kind of issues. How are we going to clean it and how are we going to pre-process them before getting into application? So, any text that we get from the collection, it will go to different stages of data cleaning, starting from identifying different kind of noise removal, and some kind of normalization, and some kind of masking. Okay, depending upon the data set. Then after cleaning, it will go for some kind of linguistic processing. This is the most important pre-processing stage. And especially every language are different with each other in different way. Right? So English may use some kind of word formation, sentence formation to express the same, but other languages may use it differently. Right? So this is a very, very language specific processing that we need to do. Otherwise, we may miss out some of the information or intricacies of any language. I'll come back with some more example on that part. Then it will go for a number of, again, stages for pre-processing. Then we will be ready with data. Okay. Now, I'll start with tokenization. So, tokenization is, how many of you heard about tokenization? And how many of you know that it is one of the biggest issues in NLP, even today? Yes. Tokenization is nothing but like tokenizing or identifying sentence, looking at the boundaries and identifies, okay, this is the sentence, and identify words, okay, looking at, because we are talking about text processing, I'll go with written text. The space between two spaces between anything is a word that's defined in a very crude way. Okay. So then tokenization is the process of splitting text into smaller units called tokens. It can be a sentence or it can be a word. So sentence tokenization, it is the process of splitting text into individual sentences. Do you think any challenge here? When you want to split a document into sentences, is there any challenge? Punctuations like doctor with dot or PhD with dots are not sentence boundaries. Right? Any acronyms with dots or any date with dot should not be considered as a sentence. Right? And differentiating between the periods which are used in abbreviation and sentence boundaries are a biggest challenge. And sometimes sentences deal with different kind of quotes and parentheses. Right? Whether it should be part of one sentence or part of another sentence, let's say some kind of period in between these parentheses. Right? So these are all challenges, may look like a very simple thing. When we are really building any tokenization, then we'll understand how are we going to do it, because sometimes it may look like a sentence boundary, but sometimes it may not. Just to give us some example, this is the sentence. Dr. Indu, an expert in AI, visited Chennai. She gave a talk on PhD research at IIT Madras. Her presentation was insightful. Examples, she discussed various algorithms. After the event, we went to Marina Beach for a relaxing evening. Okay, so now we want to tokenize it. There are a lot of issues in this, paragraph itself. So first of all, the doctor dot should not be found as a sentence boundary. It should be part of the sentence. And PhD is also the same thing. And E.G, exemplicasia, that example should not be identified as different sentences. And similarly, the other things should be identified. right? Okay, let's say we have identified sentences. Again, word tokenization is another important thing. Now, this is the process of splitting text into individual words. Do you find any challenge now? Space, hyphen, underscores, apostrophes, all the punctuations which are part of the word formation are problematic things. And in Indian languages, we have very different problem. I'll talk about it also. So we cannot just blindly remove punctuation here because they're ambiguous. And email addresses, URLs, they may have different kind of symbols which should not be split it. Now doctor dot, it should not be split into doctor and dot as two different tokens. It should be one token, right? And it's depending upon the task. Don't go with what I say because depending upon the task, the tokenization techniques will also change. Okay. And in English, there are a lot of contractions like we are, I am. Now, should we need to split them into we and re and I apostrophe with m? If you are splitting it, this re and m, which are not meaningful, can we call it as a token? Or should we substitute it with something else? Re into are, mn into am, right? So these are all challenges. That's where we need normalization techniques. Okay, so tokenization now requires normalization. And another thing people normally do in the text processing is, depending upon application, they remove stop words. So stop words are words which are not content words like nouns, verbs, adjectives kind of thing. They are functional words like articles, particles, or determiners kind of categories. They might not add much value to the whole modeling part. So people use this stop word removal again depending upon the application. So again there are many challenges here also. We cannot just remove it in all context. Maybe in information retrieval, sentiment analysis, topic modeling, these kind of stop words may not contribute much. But when you look at machine translation, question answering, or any other summarization kind of techniques, stop words play a very important role. Okay, we cannot just remove them. Okay, and ensuring important words are not mistakenly removed. For example, no pain, no gain. We cannot just remove no is just a particle, negative particle. If you remove, the whole context and meaning will go up. And when to not remove stop words? If the task involves any understanding of the context or sentiment, then don't remove such kind of words. Okay, though not, no or stop words, we should not remove them because they carry a lot of information for a particular task. So we need to tune, customize this stop word removal depending upon the task we are doing. So just don't take, okay, NLTK, that's a pipeline, I think in Python you can use. Just call the NLTK, remove stop word. It will not help you for the application that you are working on. So do some kind of analysis on what kind of task you are doing, what kind of information should be retrieved and kept as it is, and you have to write your own understanding and create a stop word removal there. And for tasks like machine translation, text generation, retaining stop words are important because they preserve grammatical structure and the core meaning of the whole context and discourse. And something called multi-word expressions, very, very interesting factor in languages. Idioms, proverbs, some kind of set collocations, set phrases which cannot be split into different forms. They always come together, right? So those kind of expressions should not be removed. The stop words within those kind of expression. For example, kick the bucket. It has a very special sense. If you remove the from kick the bucket, the complete sense of what is kick the bucket, it means died. Okay, it will go away. So now stop word removal requires identification of multi-word expressions and identification of like what task you are doing, what should be deleted and what should not be deleted. Okay, so each of the pre-processing requires some kind of pre-processing. We cannot just build these things just using 2 lines of code now. Okay. And when you come for other languages, Indian languages, let's take the negative particle itself. Sometimes it's a part of a word. It is not a separate element. How many of you know Tamil, Telugu, Kannada, Malayalam kind of languages? It's Dravidian languages. How many of you coming from Indo-Aryan language families like Hindi, Odia, Bengali? Okay, good. Gujarati, Punjabi kind of languages. How many of you coming from Tibeto-Burman language families of India? Austroasiatic language families of India? So we don't have much variety in the class. Mostly Indo-Aryans and Dravidian speakers are here. Okay, I'll take some examples from Dravidian then. For example, how many of you understand Telugu? Tamil? I could see the same number. How many of you understand both Telugu and Tamil? Okay, Kannada? Malayalam? Good. Any other language from the Dravidian part? No. Konkani? Konkani is an Indo-Aryan. Some of you can understand. Okay, Tulu? No speakers. Okay, good. So, for example, if you want to say, he is not coming, in Dravidian, in one of the Dravidian, maybe Telugu, Vadu Radu. In Tamil, Avan Baravillai. In Malayalam, Vandilla. Right? So in Kannada, I am sorry, I don't know much Kannada. Barilla. Barilla. Right? So you see the marker not here is not a separate word like what you have it in English and Hindi. Right? What is the sentence in Hindi? He's not coming? Nahi aa raha. Right? Nahi is a different word like in English. But look at the way these languages work on. They'll add this marker as a part of the word. Now, if you want to remove this kind of word from the part of that word, it is a challenging thing. So now you cannot use English model on this kind of languages. So language specific, language family specific information is required when you want to split the word. If you want to split it in a more meaningful way. Right? So I'll talk about little more on those part, how languages differ and how models should be different, how our machine learning approach should be different. Okay, all these things we will come back. So now normalization is another important thing that is required for stop word removal and tokenization. Now what is this normalization? So normalization involves converting the text into a standard format. The standard, what I mean is something acceptable by all of us. Okay, or for acceptable or required for a modeling part. Such as English might require lower casing of things because anything starts with sentence initial, they may use the uppercase, but the difference between uppercase and lowercase, Unicode representations are different. So when your machine learns, it uses all the Unicode points to learn. So you need to normalize it into one format so that it need not to learn in 2 different vectors for the same word. Okay, and expanding abbreviation depending upon again the application, and correcting spelling errors if your model should give you error-free thing, or if you are building on grammar deduction, grammar error deduction or spelling error, your data should have all the things. But if you are building on something on language generation part, your data should not have this kind of errors. Right? And some of the challenges, of course, we have a lot of variations in spelling, not only in English, even our Indian languages have this kind of thing. And dealing with domain-specific abbreviations and slang are important. And correcting spelling errors without introducing any new errors are part of, again, normalization process. Let's say I'm giving a text like, lol, that was the funniest joke ever. Okay, if you're giving this kind of thing, for generating, yes, like, scientific document, you cannot write in the research paper, lol, okay, this is what happened, right? So, some kind of normalization is required depending upon the context. Social media languages requires a lot of normalization when we are working with real-time data. Sometimes Unicode normalization is also an important factor because the Unicode rendering might look like the same, but sometimes they have different kind of values. Okay. So the values, like you see the code point in ka, u plus 0915, this is the Devanagari letter ka, and if you add nukta to it with a different code point, it also looks the same, and the first word is also looks the same, first letter glyph here also looks the same, right? Now if your data looks the same, with the same like in a particular point we need a particular Unicode values, but when people types it, or when we are converting from one data source to another data source, some kind of conversion happen, it will affect the whole values. So we should have some kind of Unicode normalization there. Okay, especially in most of our languages we use syllabic pattern of writing. Okay, unlike English, which is more of alphabetic things, right? When they say ka, ki kind of thing, k remains the same. But in our languages, for example, when you have ka in Hindi, when you want to add a to it, just add a secondary vowel. But you are not adding the primary vowel of a there, right? So similarly, let's say in Tamil, this is ka, and if you want to add a lengthening, you just add a secondary vowel marker there, right? So now the combination is, this is one code point it has, and this has another code point. Okay. For example, in Tamil, this is something like K. Okay. And you add la to this. Okay. This will become cow. It is not actually la equivalent to la, la, retroflex la, right? So, but in this context, the combination of this glyph and this glyph is nothing but its cow, right? So it may look like something like this, or it may look like something like this. Now, which one to select? It has two different values, similar to what you have seen in Hindi now, right? So in a context, we should make sure that which code point we have to use. So we need a contextual, language contextual information there. Okay. It may look like a very simple problem, but when you work with a large amount of data, this is the biggest problem, because machine will fail in such kind of context. I'm still in pre-processing. I didn't go into the actual thing now. Okay. And spelling normalization is another thing. For example, Telugu. Tarvata, tarvata, taravata. That means afterwards. Okay. This word is pronounced in, not only this word, there are many of such kind of example. For example, I come from IIIT Hyderabad, so I have a lot of Telugu speakers there. I picked up some Telugu also. They say, he came, they say, vachindu, vachadu, vachinadu. Sometimes, depending upon the variety, if somebody comes from Andhra Pradesh, you have to switch to your words for them. Telangana, they need a different kind of way of speaking. Right? Hindi also the same thing. When you come to Hyderabad, you speak Dakkini Hindi, not the Hindi that you speak, right? So every language has its own variety, and when we write it in totally different way. We have to accept it. Okay. So that's the beauty of language. That's a challenge of our NLP activity also. So now this kind of spelling normalization, if it is required for a particular task, we should keep it. If your model needs to learn the diversity for a particular task, don't remove it. So all these decisions we should take initially before getting into the modeling. That's why just copying the model from other sources will not help us if you really want to build any model. Now let's say we have taken the data, collected the data, cleaned the data. We have done some kind of pre-processing like tokenization, normalization, stop word removal, everything we have done. Now, how are we going to represent the data? We have huge amount of data in our hand. So for text representation, there are many techniques again in NLP. So it is the process of transforming a raw text into suitable format which are required for further analysis. Okay. So some kind of numerical requirement, understanding how many words are there, how many times the word has been repeated in the same sentence, how many times that particular word occurs with a neighboring word. This is called n-gram analysis. Okay. So the n-gram analysis help us to understand the lexical richness of any language. So, for example, if a concept in English can be expressed with 12 words, the same can be expressed with 2 or 3 words in other languages, or the same can be expressed with 25 words in another language. So, this helps us to understand how lexically a language is rich or not. Okay, so for that, we use some kind of techniques like bag of words, TF-IDF. I'll talk about what are them, and some kind of word I use for
that. Like different languages are lexically rich. So what was the word you used for something analysis?
N-gram analysis. Okay, N-gram. N can be replaced with bigram, trigram, or any grams. So to understand how many times a word occurs with another word in a context, that will give us whether is it a multi-word or is it something like always they come together. So that's how NLP techniques work, the predicting next word. Right? The prediction of next word is what is actually fascinating us right now when we are using any LLMs. We just give an input, automatically give a prompt actually. You ask, okay, can you please explain this concept? Automatically it just started explaining the concept every time in a new way. It will not giving you the same answer at a time, right? So that all the prediction happens using the contextual information. Who's coming before, who is coming after, how many parametric differences I have to find out. Let's say I have to go from this word length of 1 to the previous word length of some 20, 25, 100, or after that some 100 words. That's how LLMs, these large language models, they are large because they are able to capture a bigger context. Okay, so that comes from the basic concept called N-gram analysis now. And word embeddings are the next level. There are some challenges in each one of them. That's why we are going from bag of words to TF-IDF, then TF-IDF to word embedding to the current transformer-based models. Okay, so how bag of words work? A simple technique, what we will do is, we will convert the words into numerical representation based on their frequency. Okay, so conceptually, we think the whole document as a bag of words rather than the sequence of words. Split them into words, don't look at the context, that means don't look at the previous and the following word, just look at the words as bag of information. Now, step 1 here is, let's say this is the paragraph, the boy packed his school bag in the morning, the boy walked and went to school. Okay, so I'm just using 2 times the boy just to make sure how this bag of word works. Otherwise, we'll replace the boy with he normally in a real-time situation. Now, the tokenization, let's say first thing I'm doing something like stop word removal for a different task. Remove all the stop word. Get only boy packed school bag morning, boy packed walked went school. Now, the unique words here is boy packed school bag morning walked and went. Boy, I didn't put it in 2 ways, 2 times, right? So, tokenization, in the case of boy, there are 2 tokens, okay, but only 1 type. Okay, so types are different and tokens are different. Tokens are actual elements that are there in the document. Types are the unique information that you can find from the document. So, the type and token, which we call as type token ratio, TTR, again helps us in understanding the lexical complexity of a language. If the type token ratio is lesser, okay, it means the language is word level, they are very, very rich. If the type token ratio is more, the types and the tokens are almost like more types and more tokens, it may also infer something else. The richness, whether it is a poor or a, like, very rich in a particular context. I'll not get more deeper into that one, but yes, I have some slides for that one also. Okay, so sometimes languages are richer in word formation level. Sometimes languages are richer in syntax, that means sentence formation. For example, English, the word order is very, very rigid. John saw Sita and Sita saw John are totally 2 different sentences. But in Indian languages, John ने सीता को देखा और सीता को John ने देखा. I'm sorry, my Hindi is very bad, but please bear with me. This will not change the meaning because there is a marker attached with that one. There is a name, there is a ko or Raman Sitayai Parthan, Sitayai Raman Parthan. Sentence meaning will not change, right? That's because syntactically some of the languages are very, very flexible. That means you can shuffle the word, but in English you cannot do. But morphologically these languages are very rich because a lot of information. So I'll talk about the dichotomy, how languages differ with each other, in which level, and how our modeling should also be aware of about all these factors. I'm not taking more technically this session. I'm just giving you some fundamentals, but if some of you are expecting some kind of technical thing, maybe I'll share you with some kind of codes and other exercises later. Okay? Because each one of them can be exercised and we can see, run the code and see all the things. Now, you see the frequency here, boys, school, packed. The frequency is 2, 2, 1, 1, 1 kind of thing. And we are just trying to provide some kind of vector number. Right now, the vector number I just have given as 0 to 6 here. After this, now we create a table in each sentence for the presence of each word in the dictionary. And if it is there, we'll assign 1. If it is not, we'll assign 0. And with this kind of understanding, we'll try to represent the words as vectors using bag of words. Okay, there is no context here now. Now, there are a lot of shortcomings with this kind of technique. When you want to work with the bigger applications, one is sparsity of document representation. That means the document that you have given, if a particular word is not available or very rarely occurred, that is not given much importance. Less frequent words are not taken more seriously here. So they doesn't capture meaning of words. Okay, they won't look at the previous and the following words. Now, to overcome these shortcomings, there is another technique that is called TF-IDF, term frequency and inverse document frequency, that is being used. So this term frequency is nothing but total number of terms in document D over number of times the term T appears in document D. Find out this is a simple thing in a document, how many times a particular word occurred. So find out the term frequency there. And this is a local this reflects the local importance of a term. That means in that particular document, these many times this particular term occurred. But on the other hand, inverse document frequency is nothing but logarithm of number of documents containing that particular term. You have multiple documents, but there is a term like boy. Okay, and how many times it occurs in each of the document. Document 1, document 2, document 3. That might give us a clue. In one document, boy might occur. In another document, boy might not occur. Right? So this might give us a kind of balance on very rarely occurring words and very, very significant for language understanding. So this reflects on global importance. So it helps us in identifying words that are discriminative and informative across multiple documents. For example, the same sentence, the boy packed his school bag in the morning and the boy walked and went to school. We have the frequency. Now, find out the TF. The TF here is, I am again removing the stop words for my calculation. If I don't remove, you have to put it the total number of words, including the stop words. So, there are 5 non-stop words, and in which one time the word boy occurred. So, now the calculation is 0.2 here. Now, identify the IDF. So, this helps us in understanding how many times the word boy occurred and how many times it occurred in a sentence. Let's say, if I take 2 sentences separately, in each one of them it's 1 by 2, 1 by 2. But if I combine them, 2 by 2. So the value is 0. 0 means it's less important. That means it's occurring more and more time. That means it is not giving us an idea about whether it is a very important, significant word. Lot of stop words may do that one. And they kind of, like functional words occurs more often in our languages because they are the connectors to the language communication. Whereas the rare words like nouns and verbs, we use not multiple times, right? So TF, IDF, multiplying these values for each of the documents gives us a different understanding on how we can represent the words in a language, what kind of importance should be given for words in a in the doc. Again, there are shortcomings with TF-IDF, but don't think that you should not use bag of words or term TF-IDF. Depending upon a task, you can still go for BOW and TF-IDF. If these shortcomings are not a big problem for your application or your modeling part. Now, the position of the word in a text is not identified in TF-IDF. Okay, I don't know whether boy occurs with went or boy occurs with reached or the previously. That information is not there. Again, it's a word information representation in isolation. So now meaning of words with, again, the similar meaning, that means polysemous or homophonous forms. Same word may have multiple meaning, or same word can be represented in two different forms. Those informations might not be identified using this TF-IDF. And relationships between words that frequently appear together, that context is also been missed out. Okay. So to overcome this shortcoming, the another technique for representation is word embeddings. Okay. So word embeddings is a kind of, again, word representation. This is where all our language models comes into the picture. Okay. So that allows words to be represented as a dense vectors. Vectorization of the actual words. Okay. So that you understand how much of these vectors help each word, so that we can infer something out of it. Okay. So each word is mapped to a unique vector. If boy, there is a unique vector there, and similar words are represented by vectors, and the vector numbers may be little closer. Okay. So it actually captures both syntactic and semantic relation. Syntactic is nothing but sentence structure. Semantic is nothing but the meaning. Okay. So word embedding can help us. So now it is being used in by different techniques. I'm not going more deeper in each of the technique. I'm just introducing them again. Something like word-to-vec, glove, Fostex. These are some of the word representation techniques. Okay, each one of them have their own advantages and disadvantages. We can use one of them. Okay, I'm not going deeper. Sorry for that. And how does it help us? Let's take this diagram, the vector math here. There is a vector for king. Okay, and there is a vector for man. And there is a vector for king minus man. Right? Now, the relation between king and man and king minus man, there is some kind of relation that you can find. From there, there is a vector for woman, but there is no vector for queen, let's say. That is not there in the document, but we have to represent it. So, the relations take something like queen is nothing but king minus man, but plus woman. Okay, this kind of like prediction can be done using this vectorization. Okay, vectors with similar sense will occur together. There is some kind of similarities in their vector representation. Okay, so in one way, this helps us in understanding if the word is not there in the document, we can still infer the meaning out of it. It's little magic now. Okay. Yes, we'll find out the dot product similarity there. Again, there are some shortcomings. Okay. Okay, now we identified syntactic, semantic properties. But the problem is, if the word occurs in very rarely, TF-IDF might help us there. But can we like mix TF-IDF with word embedding? Then what happened to the word order? TF-IDF will not help us there in the word order. Word embedding will not help us in the word order. Because as I said, in English, the word order is very rigid. I don't want to generate a sentence like the boy, the girl saw, which is meaningless. I want to generate it as the boy saw the girl, right? So that's why contextualized word embeddings comes into the picture. Okay, so the current, or the recent current, I could say at least, some of the techniques like Elmo or BERT, or kind of thing which helps us in identifying the complete context, maybe the complete sentence context, as well as the embeddings of each word. Okay, it's a little improved version of, it uses the same embedding but in a lengthier context. Okay, and again in the BERT, mostly BERT is a Google's thing, and it uses only kind of Western language specific thing. And we have MBERT, multilingual BERT, and we have Mural, specially designed for Indian languages. We have XLM Roberta, we have different kind of techniques that are being given by different industries these days. Okay, so all these embeddings will help us. It worked in a different way. Some of them worked in encoder decoder way. Some of them works only decoder only specific way, like bot kind of models. Okay, so these are all very advanced models these days. So maybe we will talk about it if we get some more workshop in some time. Okay, so this way we can represent the text now. We collected the data, we done the pre-processing, and we have represented the data by using some kind of technique now. Okay, we have stored the data. Now, what kind of analysis is required? Let's say I want to build a machine translation. I have parallel corpora with represented format, vectors of both the things. Now, is there anything else I have to think about it now? Can I just go and run the model? That's how. If you have a huge data, don't worry about this kind of analytical parameters. You can just go away. But as I told you, most of our languages, Indian languages, are data scarce languages, but NLP is a data hungry one. Give me more data, only then I'll produce the model, right? So with the data hungriness, the data what we have, 1 crore, 2 crore sentences also will not help us. Okay, we need billions and millions, billions of millions of data, right? So in that context, if the data is quantity-wise less, we can add on some kind of linguistic richness to the data. Give some more context, give some more knowledge to the data. Okay, that means annotate the data with some kind of information. So that will give you some more information, right? So let's say if somebody asks us, where are you coming from? If I just say Hyderabad, you will not understand which part of Hyderabad I am coming from. If I say, I'm coming from, let's say I am coming from Telangana, you will not understand which part of Telangana I am. If I say Hyderabad, you will not know which part of Hyderabad I am coming from, right? If I say just IIIT, in like Andhra Pradesh and Telangana, there are 2 IIITs, which IIIT you will not know. So specifically, in a more structured way, if I given information, okay, IIIT Hyderabad, it is located in Gachipowli, near like, sports stadium or something. If I just give a lot of information about myself, then you will easily locate, okay, this is what, this place is what I meant, trying to say, right? So this kind of adding extra information to words and sentences will help us in, training when we have less amount of data. Okay, because getting the data on par with English and other languages definitely takes a lot of time, and all of us should contribute in a way, or writing blogs, Wikipedias, generating lot of data every day. Otherwise, synthetically building the data also has their own issues. That's what most of us are doing, because when we don't have data, when we want to work with a bigger model, synthetically build some more data, but that may have some kind of other, implications. So now this data analytics is another important thing we need to go on. The first thing what we need to understand is stemming. So stemming is again a process. Again, it's a textual thing I'm talking, I'm not going into the speech level and other thing. So stemming, it refers to the process of slicing a word and remove all the grammatical information it carries. For example, boys, there is an S marker which gives you the plural. Books, there is an S marker. But if I say he books the ticket, what is S there? Is it a plural marker? I read my books versus he books the ticket. These 2 books are different, right? And S is also different. One is a plural marker, another one is an agreement marker with the subject. Since it is a present tense and the subject is he, she, it, singular forms, add the S marker, right? So now these grammatical suffixes, I'll say in English mostly suffixes, add on some kind of information. So if you want to work on some kind of other application where you don't need this functional element like stop word removal, you can even remove the part of suffixes from your data. And you can take only the important part that need to be analyzed. So that is stemming. And in linguistically, I would say it's a little problematic thing, because the one we get after slicing the thing might not look like more of meaningful element, right? For example, arguing will become argue, flies become fly after removing the information. Playing might look like a very meaningful form, play, and caring will become like car. News will become like, we should not remove S there, but if you are removing in a word without understanding, remove all the S, it will remove S everywhere, right? There also we need to have some kind of intelligent way of processing the text. Then lemmatization, on the other hand, is little like, over improved format, I could say. Instead of deleting the suffixes, removing the keep the remaining part, convert the remaining part in a more meaningful way. Lemma is nothing but the root word. In a dictionary, if you want to go and search for a word, you are finding only lemma and their explanation. When you have books, the lemma is book. When you have play, plays, playing, played, the lemma is play. Okay, after removing all the functional elements, whatever is remaining is called lemma. Okay. So lemmatization, again similar to stemming, but after removing the thing, keep the form which is meaningful, which is there in your lexicon as one of the forms. Okay, so you understand the difference between the thing. Now, they are mutually exclusive because lemmatization requires more of resource thing, because you need to convert to the acceptable format, whereas stemming, you have a number of suffixes, match with the suffix and remove the part and you will get the output. The output for the interchange kind of information you will get in stemming without E, whereas in lemmatization you will get with E. Okay, and depending upon the context and the model that we are working, we want to select whether we want stemming or a lemmatization. This is fine. But there is something called analysis that we want. Let's say I have removed interchanger ER from there. But ER has some kind of specific information. Right? It is some kind of agent. Let's say player. That ER has some kind of specific information. I want to even capture that specific information in my document and keep it and represent it. Okay. So lemmatization stops in a place where once it gets the lemma, it stops. The task is over. But if I have to get some more grammatical information from this word, we have to go for something called morphological analysis. So what is this morphological analysis do? So morphology is nothing but a study of word formation. Okay, how words are being formed. So as a human being, we have some kind of cognitive ability to form any new word. We know how to use Google as a verb as well as noun. Okay, I say I Googled it, verb, it's my Google document, adjective. Okay, it is the Google noun, right? So we know how to use any new word that comes in our languages in a proper place with a proper suffixes. Okay? But this ability we need to give it to the machine. The machine should understand any word given and identify the lemma plus identify the grammatical properties of any extra prefix, suffix or infix, circumfix. There are different kind of thing languages works. Very beautiful languages, they have a different kind of thing, but what we normally expose to mostly prefix and suffix. In India itself we have a language called Santali. Have you ever heard about it? They have infixation. They have different polysynthetic way of expressing things. I have some examples to show that one also. Okay. So language have very complex phenomena. Now the same feature what you have in your language will not be there in another language. So this morphological analysis is another biggest challenging factor for us. Again, we are still in the pre-processing stage again. So here we are analyzing the structure and form of words, and we are breaking down the words into morphemes. Morpheme is a technical term. It means any meaningful element within a word is a morpheme. Okay. So book is a morpheme. S is also morpheme. Whereas book is a free morpheme. It can even occur book in other place. But S is a bound morpheme. It cannot occur on its own. It always needs somebody to be attached to. But both are morphemes. Both are meaningful, smallest meaningful units. Right? So now analysis, this morph analysis helps us in breaking down words into different kind of morphemes. So it helps us in understanding what kind of prefix we have, suffix we have, and other kind of inflections. I'm sorry, I'm using some technical term. If you don't understand, please bear with me, but I'll give you in a very simple way. Inflections, again, the S is an inflection. Okay. And important in languages with rich morphology. I'll give you some example. Let me take a language called Turkish. This is morphologically very, very rich language. You see, this one particular word has a lot of morphemes, lot of information within a word. Okay, only Turkish behaves like this? Don't we have in India languages with this kind of thing? Yes. We are also rich in having something like this. In Telugu, I give one example. This is a word, not a sentence. Pagala gottinchi pettamani nebba dalichukolekapotunnanu. One word. In Indo-Aryan languages, you will not find such kind of thing. One word having so much of information. Right? People might not utter it every day, but it is permitted to create such word of this kind. And we have lot of such words every day in a corpus, which cannot be learned by the machine, which has some kind of issues. All these things are problematic things when we are working with different language. That English technique will never use helpful for us then. Okay, so our pre-processing should be very, very rich there. Okay. So you see different kind of morphemes here, and each morpheme has some kind of grammatical information it carries. So there are languages which are of different kind of typology. There are languages which are isolating, like Mandarin kind of thing, where each one of them are written in separate space or thing, whether it is ED or S, everything is separate marker. So morphological analysis is unimportant there. You don't need to have it. And stemming and lemmatization is not required. So this kind of pre-processing, these languages need not go ahead, right? But there are languages which are agglutinative. That's what we saw in Turkish, Telugu, and lot of Tibeto-Burman languages of India. Okay, and Austroasiatic languages of India, other than Indo-Aryan, most of the languages have this feature. And Marathi, to the fact, Indo-Aryan, but it borrowed lot of features of Dravidian. Their word formation also very, very rich because of the contact with the language. So the language, India is a linguistic area, we say. So this means, though we have different kind of languages, there is some kind of commonality across all of us in terms of language, linguistic perspective. So though Indo-Aryan comes from the sub-branch of Indo-European, where English and Hindi or Odia, all of them are coming from the same branch. Since it's been there in India for a longer time with other language groups, it also acquires other language thing. This phenomena is called as convergence. So the convergence is much, much higher in all our Indian languages. So the agglutination you could still see in Indo-Aryan languages. The inflectional or a fusional pattern, you can still see it in the Dravidian languages. Okay, so this is not a strike dichotomy saying that Telugu is always agglutination, Telugu also fusional in some time, or Hindi is always fusional. For example, I'll give an example in English, a word like disestablishmentarianism. It still look like an agglutination, right? Lot of information. There is a disestablishment, mentarianism, right? Lot of morphemes are part of the word. But English is normally not very rich in morphology, but in some cases you could even see the agglutination, this kind of thing. So what we need is, this is a very rare word in the document. Okay, let's say, if this rare word need to be understood by the, next models in a pipeline, right? So that's where morphological analysis is helpful for us. And especially for Indian languages, without having a morphological analysis as a pre-processing, you cannot go ahead. English, most of the English models will not use this technique when they do that one. They'll straight away go for part of speech tagging. Okay, but Indian languages, in the importance of morphological analysis is enormous because word carries a lot of information. Word is loaded with too many information and it is embedded here and there. So we need to break them everything. Only then we can go for the next. And another interesting thing is polysynthetic languages. These are all again another difficult type of languages where there are morphemes, but all of them are combined together and formed as a word. In agglutinating kind of languages, if it is a verb, it carries only verbal morphemes. If it is a noun, it carries only noun morphemes. But polysynthetic languages, on the other hand, combines verbs, nouns, adjectives, adverbs, all kind of categories together. It's very, very difficult to identify what it means to what. The glossing of morphemes with the sense is difficult there. They are again highly, highly difficult to carry forward for NLP. So this pre-processing is important for agglutinating languages and polysynthetic languages. Without having a good morphological analyzer, we cannot go forward. But let's say Hindi, you can just skip away this kind of thing. You can go forward for the next step. Okay, we have done some kind of morphological analysis. What next? Because our aim is to add some more extra linguistic knowledge to the text, right? So we are able to identify words, we are able to split them, we are able to identify what each morpheme means, try to understand the grammatical properties, all fine. And I think I forgot to mention one more problem with Indian languages is Sandhi. Sandhi, I think you might have heard about it. This Sandhi, there are two types of Sandhi because when two morphemes comes together, there is some kind of changes, like some kind of chemical changes happen and there is some kind of addition, deletion, elongation, lot of things happen, right? And if Sandhi happens within the same category, not a problem. You can still keep it. You don't need to worry about it. Morphological analysis will take care of it. But if Sandhi happens across two different categories, for example, in Telugu, when we are working with languages like Telugu and Malayalam, we always encounter this problem of Sandhi. We need another module called Sandhi splitter. Other than the morphological analyzer, we need a pre-processing before going into the morphological analyzer, build a Sandhi splitter, then go for a morphological analyzer. So maybe I'll take one example from Telugu. What does it mean? Telugu speaker, intikochadu. It's one word. Look at from the word point of view. It is one word, but it has something like intiki plus maybe bachada or ochadu. So this is to the house and came. He came. Okay. So now this is a noun and this is a verb. When you provide this as an input to the morphological analyzer, since there are two category information, morphological analyzer fails there because it identifies the category wise analysis only. The task of morphological analyzer is, if it is a noun, split it with noun suffixes. If it is a verb, split it with verb suffixes. When this kind of stylistic variation, normally writers do all these things, they want to keep it everything together, right? So this is another biggest problematic thing when we are working with the Indian languages, especially with agglutination and polysynthetic kind of languages, even Tibeto-Burman languages and Austroasiatic languages of Indian continent have this kind of issue. Okay, so now we have to develop something called multi-token identifier. Okay, there are multiple tokens within a word. This we call in Indian context as a Sandhi splitter. Okay, these are all external Sandhis, not an internal Sandhis. Externally, two different words which can be written this way, but people are writing this way. So split them properly and get it done. Okay. By the way, all these techniques, normally any computer science person who knows deep learning will not do it. You can ask me, why are you teaching me all these things? That's the problem. You take the technique, deep learning technique, you take the data, but you will not gain the expected accuracy of what you want when you are using just deep learning knowledge. Because NLP is a highly interdisciplinary. We need to understand the language pattern. right? If you understand the language pattern, properly do the pre-processing, then go for the deep learning, it works better. Okay. Otherwise, over the night, I want to build a model. You can build a model and let's say you are creating a precision rate of something like 60 or 0.6. If you want to change 0.6 into 0.61, highly difficult in machine learning. Okay, that means you have to go and tamper on the data again. How to tamper on the data? Understand the language nuances. Then go for the actual modeling. Modeling is these days, it's off the shelf. You just can go Hugging Face, call the model, give the data, it works. But before giving that data, I'm more interested, I'm coming from that kind of area. Before giving from the data, let's make sure what kind of data we are giving. Selecting models are again, of course, a challenging thing, but I would say data matters. NLP is data centric. If data is of structured format with all informations which are nuancedly placed in a particular order, we cannot build the model. All the models can be a good model for assignment purpose, but not for the real-time purpose. Okay, that's why I'm just trying to give these fundamentals here. Next step, we have done tokenization, stemming, and morphological analysis. Next step is go for a part of speech tagging. English definitely, as I said, skips all those things. Straightly go for the part of speech tagging. So here they assigns the grammatical categories to the word. I think in schools you might have studied about part of speech, nouns, verbs, adjectives. How many part of speech you know? All of you forgot your English grammar. 8 part of speech in your school days, right? But when it comes to NLP, we will not work with only 8. Okay, we will work with multiple categories. There are sometimes we use fine-grained tag set, sometimes we use coarse-grained tag sets. In India, we have a very standard ISO standard format, which we have developed, which is called BIS, Bureau of Indian Standard, for pure tagging, especially for Indian languages. We have developed almost around 24 plus categories. You cannot, what are those 24 categories? Because I know only nouns, verbs, adjectives, and verbs. There are many more linguistically, there are many more categories. Maybe we will talk about it in detail in one later also. So this is again a fundamental thing. And again, one more question, why do we need POS tagging when the morphological analyzer gives us, it is a noun with this suffix, it is a verb with this suffix, why do we need POS tagging? Because morphological analyzer throws all possible analysis of a word. If I give a sentence like time flies like an arrow. Okay. How many sense are you able to get it? I'm not giving any context here, just time flies like an arrow. So if I call it as a noun, if I call it as a verb, and if I call it as, since there is already a verb, you cannot call like as a verb, and I call it as a particle, a comparative particle, and a determiner and noun, you understand what I try to say. Hopefully. And if I call both of them as nouns, and if I call them as a verb and as a determiner, are you able to get the second sense, what I try to come up? Interpret it. This flies as a verb in one place, and I interpret it like as a verb in another place. One is time flies like an arrow. Like normally we say, okay, we don't have time because it flies like an arrow. Flying as an action. If I have something like time flies like an arrow, like fruit flies like bananas, like similarly time flies like an arrow. Flies as a noun. Are you getting the second interpretation? Right? Now you have two analyses here and two analyses here. In a context, which one to be selected? Morph analysis throws both analysis. It will not know because it works in word in isolation. It will not know the context, right? So we have to go for a little more context to select which category it belongs to in a context. That's where part of speech is helpful. So part of speech looks at it and says, okay, there is a verb. I have to select this one as a verb if the following is a particle. I have to select this one as a noun if the following is a verb. So it uses some kind of contextual information. Like in word embeddings, how we are trying to go for the next level. In part of speech level also, we are trying to go for a smaller window of context, not complete sentence, at least +2 and -2 context. We will take it over here. So this is a kind of, again, disambiguation process. Because WSD, that is called word sense disambiguation, is another problematic case. Earlier, before all the large language models came in, but nowadays contexts are much more comprehensively understood by the model because of a larger context of information. Otherwise, the rule-based, statistical-based, they fail to get that kind of context. It throws out only one context based on the frequency. So it uses the frequency knowledge there. So in a given document, I learned it in such a way that this word occurs as a verb multiple times, given the factor that this is the thing. So their frequency, term frequency comes into the picture. Okay. That also you can tweak. Okay, don't give me using the frequency, give me with something else. That POS tagging, we use something like hidden Markov models or conditional random field kind of techniques to train the POS tagging. So we can tweak how much of template of context we need to learn. That's all like tuned. Okay. So now what it does, it gives us the part of speech and each of them, like each guidelines, if you are following a pen tree bank, they have a different kind of tag. If you are following BIS Indian standard, we have a different kind of mnemonic forms. JJs are adjectives, RBs are adverbs. There are mnemonic forms that we need to understand to process it. Okay. And the basic POs are something like, I'm just giving only basic POs, not even all the POs. There are some categories, we call them as open class categories. And some categories we call them closed. Can you guess why? See, for example, nouns, proper noun, verb, adjective, adverb or interjections are open class. Whereas adpositions like preposition, postposition, auxiliaries, conjunctions, determiners, numerals, particles, pronouns are closed class. So all words in a way is ambiguous. Okay, sometimes words, even with the closed class, we can have that pattern. But of course, in open class, it's much more higher. As you said, all open class words are openly, you can add any new words into this list. These are the things that are very, very important when we are building new models, because any new model should understand open class words more often. Closed class, it's already there. You cannot create a new pronoun, you cannot create a new number word, or you are not creating any new prepositions or adpositions. It's already there in a language. Maybe it might take 100 years to add a new pronoun if you want to have a new pronoun for a particular gender. Or some more years, right? It's not that easy, language adapts to that one. So now, based on the open class and word class and other important things like punctuation symbols play a very important role. We cannot just throw away, because in text processing, these are the important things which helps us in understanding how to interpret a sentence, where to pause, okay, how the meanings are different if you don't have a comma and if you have a comma. All these things are important, so we cannot ignore the other. I'm not again going into more deeper here. Okay, I'll just tell in a more descriptive way. Once we annotate the data for part of speech, because in machine learning world, everything works with annotation, data annotation. We'll take the data, clean the data, pre-process, tokenize, normalize, then do some kind of POS annotation. After POS annotation, we will use some kind of either statistical or a rule-based. Rule-based are becoming very, very obsolete and also very difficult to build for languages. Actually, in POS context, statistical models proved to be the better model than the machine learning model and deep learning models, truly speaking. Okay, and in statistical or machine learning, there are many techniques that are available because it's a kind of classification kind of task, right? So you give a word, it has to classify whether it is a noun, verb, or adjective kind of thing. So we have to apply some kind of classification technique to build the model there. And another important thing is named entity recognition. In a document, we may have a lot of named entities, proper nouns. Proper nouns cannot be ignored as such, and they are also ambiguous, right? So let's say Kaveri, Kaveri can be a river, Kaveri can be a name of a person, right? Or Kamal, Kamal can be a lotus, or Kamal can be name of a person, right? So these named entities are again important thing when we are processing any text. Identifying named entities are helpful for a different domain. Let's say you are working with a something like medical domain. Identifying that paramedical factors or names are important there. In legal domain, there are named entities which are very, very crucial for legal perspective that has to be identified, right? So this is again one of the important tasks. It classifies the named entities into multiple ways. Either it is a personal name, organization name, or is it a location, or is it a data time expression, or a monetary value, or percentage. Every modeling requires different kind of named entity. You don't need to fix with one named entities, whereas part of speeches are mostly fixed elements. Okay, because it's always noun, it's always verbs kind of thing, but named entity will change according to the application again. And here again we annotate the data, we'll take the data, annotate the data and use some kind of machine learning. Again for named entities, it's a classification task. You have to classify. It's not only one word, multiple words sometimes. Right? When you say Jawaharlal Nehru, you have to classify both Jawaharlal Nehru as a person name. Or if you say Jawaharlal Nehru International Airport, you have to classify the complete thing as one kind of artifact. Okay, so and Jawaharlal Nehru Auditorium, you have to classify it as a kind of location or institution or other, what is that? Sorry, I didn't get it from here. Or a location. Okay, or artifact. It's an auditorium built by a human being, right? Or Jawaharlal Nehru Street, that is a location, right? So we cannot just simply leave out one word. We have to group them together and identify this. It's like a multi-word expression, what I told you earlier. It's like a multi-word expression. So it needs different technique. So normally annotations will be done. There are a lot of annotation tools that are available because anything that we need a easily annotation tool, and sometimes it should be automatized. We should not annotate hundreds and thousands of sentences. We will annotate only few sentences after these few zero-shot techniques came in picture, and then we will create synthetically more data and build the models. This is the new technique, but otherwise, human crafted gold data. This gold data is always reliable. Okay, so gold data should be used only gold data should be used for testing any model. You cannot use machine generated data for testing it. That's an NLP ethic. Normally we follow. So once we do that one, we'll go for parsing. Okay, so parsing is again a completely bigger task to be done. Again, deeper task to be done. It at least requires 2-3 hours of talk, but I'll explain it in one slide. Okay. So now this, once we understand the word and internal structure, named entities, part of speech tagging, we have to understand the complete sentence structure. How each word's related to each other. When I say the boy saw the girl, what is the relation of boy seeing and girl seeing? Boy is the agent who is seeing, girl is the one who is being seen. Right? So there is a subject and object. There is some kind of semantically also, someone is an agent, someone is the one who is benefited or affected by the action. Okay? So this kind of linking of information is required. Okay? So for that we will go for parsing, and parsing is again is nothing but giving deeper linguistic knowledge to the text. There are different ways of doing it. Okay, so how many of you know Chomsky? Noam Chomsky? As a politician or as a linguist? So he's a great political criticizing person, and also not a politician actually, and also he is a great linguist, great scientific person, the one who started in MIT the formal language theory, your automata theory, all these things comes from him, right? So he has actually, I could say, the father of syntactic analysis, still living syntactic analysis person. His idea of analyzing the languages are more of generative part, seeing at how the words are being generated, combined together and generated. There is a school of thought theory here. And now for the computational purpose, that theory is not useful for us. So I'm just going to say here, there are other acceptable theories too, but the most popular theory that we use in sentence understanding and analysis is dependency theory. Okay, so this theory's thing is every sentence will have a head. Okay, let's say we have a friend group, we have a head in the friend group who will plan everything. Okay, or we have some other dependence of the friend who will always depend on the planning person. Right? Similarly, in a sentence, there is always a head. And this head has a lot of dependents. It's a very simple thing. I'm not taking the family structure here because I don't want to say father as the head all the time. Mothers are also head. Okay, there is one head or two heads, but a lot of dependents here. Of course, all children are dependents. You are still depending on your parents. Right? So similarly, in language also, every sentence have a head and all other words are dependent on one of the words in the sentence. So for example, when you say the cat sat on the mat, cat is the subject and on the mat is a location. Right? Now the cat, the is dependent on cat and cat is dependent on sat and mat is dependent on sat, whereas on and the are dependent on mat. Chunking them. Okay, on the mat, chunk them. In within the mat, on the mat, the head is mat. All others are dependents. Okay, and the cat, chunk them as one group, and cat is the head and the is a dependent. And in a complete sentence structure, saw is the head and cat and mat are dependents of sat. Got it? So this is called dependency analysis. So what is the benefit of doing this one? It helps us in understanding who is the subject, what is the syntactic role of each of the word in the sentence. So now when you are mapping it with any language, when you have this kind of representation in both the languages, when languages have different kind of word order, it will not affect them. Whether English has SVO order or Indian languages has SOV order, this syntactic structure helps us in understanding there is role of each word in a language, how it is placed are language dependent. Okay, so this is a very, very deeper information that has to be built. Again, we will do a lot of annotation. This annotated text for parsing, we call it as tree bank. Okay, so tree banks are the most important resourceful thing for NLP. But how far the current technology you are using it, we are not it. Like, English definitely uses a lot. Stanford has stanza tools. So stanzas parser is the most popular tool again. And there are different kind of techniques. Tools are available using transformers and other deep learning techniques. And there is from IIIT Hyderabad, we have also initiative on building different kind of Indian language tree banks using Paninian theory. Okay, dependency again a kind of Sanskritized Paninian, one way of looking at it from the Paninian perspective. And there are Russian linguist based approaches are there, also there. And there is again European understanding of dependency is also there. But there is something called universal dependency. They are trying to build multiple tree banks for multiple languages. It's an open source. You can go and see universaldependencies.org. From India, we have also contributed some data for Indian languages. So we had to, annotating the tree bank is not an easier task because they have to understand the linguistic nuances and they have to understand how the tagging system works and what kind of guidelines we are preparing, what kind of language specific features that are captured in the tree bank. All these things are important because every language, when we were working with this kind of task, we understood languages are massively different. They are not the same. Lot of differences across languages. Okay, so all these things are captured through this kind of tree banking. And after the tree banks are built, we'll build using some kind of machine learning technique. What are those machine learning technique? I think that's not a big problem. I would say that you can easily, because every day new machine learning technique comes. It's not a fixed thing, but all these things are fixed thing. This is the fundamental now for us. Now, let's say we have done this one. Now, finally, can we generate a model? I'm kind of taking here as a machine translation because that's my specialization. But there are different kind of text generation also we can do. Okay. So, for the text generation like machine translation, where there are two language data and knowledge that are required here. So, the pre-processing helps us. We have a machine translation in our in-house machine translation, which we have built as a part of Boshini initiative by Government of India. And even AI for Bharat here, they have Indic Trans machine translation system. So we have multiple machine translation systems that are available these days in the market. mostly for free because nobody likes to pay for the translation because that's a human mindset, because I don't want to pay so much for taking this kind of service. So definitely most of the machine translation services are for free. But when it comes to generating this kind of machine translation output, now there is many other challenges. Again, I could say in NLP, the most challenging thing is machine translation. Okay, and also multi-domain question answering techniques. Okay, so there are other, of course, applications are also as equally challenging, but here the translation is a knowledge-intensive activity in terms of we need to understand language in different perspective, not only from the textual perspective, the knowledge of culture, knowledge of pragmatics, knowledge of the whole context, discourse, everything should be taken care. So we need to have higher level of annotation techniques, not only stopping at parsing. We'll go for semantic parsing, we'll go for discourse parsing, we'll identify anaphora, referential and other patterns. There are many other annotation techniques which I haven't covered here, but we need to do when we are going for machine translation for a proper, accurate, fluent output. Okay, but till now most of the machine translation output we are not happy. That is true. Maybe it might not work that well like it works for English Spanish or English French kind of pairs. That's because they have similar kind of linguistic similarities. But with, as I told you, in India, our languages are not that similar, right? So there are a lot of divergence across languages. How we have convergence, similarly divergences are also there. Okay, so now it is a process of automatically translating the text from one language to another language. Now there are a lot of techniques, rule-based. That was the first initial thing. In India, 1980s onwards, we have the effort on building machine translation. It's not a new effort anymore. In the field of AI, the first application people tried is machine translation, especially in the during the time of Second World War. They want to give secret messages from one place to another place, so they will encode their whole information. The other party should decode it. Okay, so that itself is a kind of machine translation, translating encoded information into other thing. Okay, so it's a first application, but it's also failure application initially. So during 1920s or 25s, governments, especially US government, started pouring a lot of money in building machine translation, because that time no machine learning, no deep learning, no statistical modeling. Okay, only what we have is a mainframe computers. So they initially thought that building a machine translation is an easy task. It just give two language, give a mapping, it produces the output. But soon they realized it is not the case, right? So when we have something like that, the sentence like he found his train in the pen, it cannot be just translated without understanding the complete context. There are a lot of semantic barriers. So there is a committee called ALPAC committee, Automatic Language Processing Advisory Committee. So this committee reviewed the efforts during the time in 1920s, 30s, because they spent a lot of amount in building machine translation system. Then they found that, okay, building a machine translation is an impossible task, let's not do it. So a massive effort has been stopped from then. Only few efforts in Russia and European places have been going on. In India, we definitely don't even have computers during that time. Okay, only during 1980s, there is some more increase or improvement in the computer systems. Also the understanding of language from the linguistic point of view. After Chomsky came into the picture, a lot of generative understanding, a lot of different kind of other school of thought came in understanding the language perspective. Otherwise, most of the time the language understanding is like a grammar, descriptive grammar, sutras. That's it, not more than that. But the cognitive perspective is not being taken much seriously. That's what very important, because we are generating the language. Okay, we are not just using the language, we are generating the language, right? So the linguistic side as well as the computer science side, there are a lot of improvements happen, and rule-based approaches are becoming very popular, but again there are a lot of shortcomings. Then statistical, after 2000 or late 90s, a lot of statistical approach have come. Computer systems are also getting a lot of improvements in terms of their memory, processing and other stuffs. And in linguistic also, we are trying to build a lot of data. Internet has been there. And only after 2000 something or something, machine learnings are becoming very popular. Linguistically also, we are trying to build, a lot of people trying to build linguistically annotated rich data sets. Then now, right now we are living in the machine learning era where we have a high processing computers, we have also rich annotated data. So that's how this OpenAI and other kind of Google, Facebook are able to build like very rich language technology tools, right? So both the sides we need to have an improvement. But now another side, okay, school of understanding is take just data, raw data and language and understanding happens. It happens, but as I told you, it will not go beyond that limit. So NLP is not a solved technique. Let me say it very clearly, NLP is not a solved technique even today, though it has attained some kind of stage. Maybe earlier it is giving 40% accuracy, now it's giving 60-70% accuracy, but it is not on par with the human being for any of the application even today. Even for English or Indian languages, we don't even think about it. We don't have even high resources for our Indian languages. Building resources itself is a big contribution for our languages. So that's how machine translation research again traversed for years. Now with the kind of techniques like parallel data, rich annotated parallel data, and again deep learning techniques, we are able to build some kind of machine translation with high computing facility again. If we don't have a high computing facility, building a machine translation using simple Colab might not helpful for us also. And there are a lot of challenges because handling the complex grammar, syntax of languages, and translating idiomatic expressions, cultural nuances, lack of parallel corpora, and named entities, how to translate them. And New Delhi, I don't want to translate as Nai Delhi, but it should be kept as a New Delhi, right? There are a lot of other issues in translation because we all, in India at least, we have multiple translation of Ramayana and Mahabharata or Bible. We are not happy with any of the translation. Similarly, we will never be happy with machine translation, but it helps us in one way where the information access is faster. We don't need to depend on human translation all the time. You can just in a fingertip translate everything. In a fingertip, you can communicate to some people if you don't know the language. But there are still some issues. That issues are research problems for us. Those are the issues you, as students of this particular program, identifies them, try to build it, fine-tune the existing machine translation for a particular purpose. Okay, I'm not going more deeper, I'm just telling a simple way. Let's say we have everything in hand. We have data, processed data, understandable, annotated data, and we also have a technique. Now, the next step is we need to build a model, right? So, model building, I'm just taking it as a conclusion because of our time constraint. So, we have to select appropriate model. Either it is a transformer model or a bird-based model or multilingual model or a domain-specific model or domain-aware model. Okay, so there are different techniques and even like LLMs like Llama 3, right now Llama 3 or any other Mistral, Falcon. There are a lot of LLMs that are available. Either we can use it because all of these models are coming up with their own embeddings already. They have huge amount of data. They already learned the data. The word embeddings are already being created. So you use that word embedding to build the model with some more data. So that's what we do. And we will train the model on the pre-process the data and validate them, fine-tune them. There are a lot of processes, we keep doing it. And training data is different, testing data is different. While developing, we need a different kind of data. The mixture of these data should not happen because when you put the test data inside your training, machine learns and gives you proper output for the test data. So that cannot be taken as a good validated data. So we have to follow some ethics when we are building the model. And we'll do some kind of evaluation. Each of the model requires different kind of evaluation. A morphological analyzer will be evaluated differently, POS differently. Each one of them have different kind of evaluation criteria. Machine translation is evaluated using different kind of automatic methods like BLUE scoring, CHRF++ scoring, or word error rate scoring, or human evaluation techniques. So that is again a huge area of research in NLP itself, because evaluation is the most important thing. How do we scale a particular model is the best one. The leaders board, understanding which model is on the top for a particular test set. All these things are again important thing. And finally, we'll deploy it for a real-term application. And NLP, anything that we do, we have to keep monitoring it. As I told you, it is not the final thing, right? And continuously maintaining them, using it for the real-time purpose are important. Okay, so all these things, I might take at least 2 hours of talk, but let me not get into that one.